So in our previous video, we have integrated our login and register component with Web API. We have seen how to call Web API methods and how to trap errors at client side. We understood the basic concepts and it is working quite well, but definitely this is not a best approach. If you have only one or two components, then it is fine to trap errors like this in components. But if you have thousands of components, this is really a bad advice to follow this approach because we need to repeat this code in all the components. Although we can write this error trapping logic in our service as well, but we may have hundreds of different services as well in the bigger applications. Then also we need to repeat this error trapping logic in all of our services. This is a very serious anti-pattern and we should never repeat our code. Also, if something needs to change with the way we handle errors, for example, suppose later we decide to log all the HTTP error in a database, we have to update each and every component or service if we follow this approach. Angular provides HTTP interceptor to intercept all HTTP requests and response to transform or handle the error before passing further in the chain. We can use HTTP interceptor to create a global error handling middleware, just like we had created in our Web API to solve this problem. So in this video, we are going to add an interceptor in our Angular application, and also we will make some changes in our Web API as well to return error in more consistent way throughout the different controllers. So without further ado, let's implement an interceptor in our Angular application to handle the error globally next. So we will add an interceptor as service. We can also use Angular CLI to generate an interceptor using ng generate interceptor and provide the name of interceptor. But I am adding the first interceptor manually so that you can understand the concepts deeply. Let's export the class as we need to use this in other modules. Name it HTTP error interceptor service, and this class must implement HTTP interceptor. And any class that is implementing HTTP interceptor must have a method name intercept that should have two arguments. First one should be the HTTP request that we can intercept here and transform it as per our requirement before sending it further in the chain. Let's name it request, and type of this argument is HTTP request, and it is a generic type. We need to pass the type of data here that should be carried by this request, but we want to make it a generic and we do not know what kind of data a request will get here. So I'm going to use any here, and we can also use unknown as well here. And the second argument of this method typically is a function, or better we can say it is an object of type HTTP handler that provides us a handle to pass the transformed request to the next interceptor in the chain. We typically return an observable of event stream here in this method using the next dot handle and pass the request here. This is very important. If you do not call this next handle, you will break your application, as your request will not pass further in the flow of application. We can perform some operations on the request using some RxJS operator on this request before sending the same to the next interceptor. We will look at that shortly. But before that, let's just write something before this return statement in the console. Let's say HTTP request started. So this is the typical setup of an interceptor. And finally, in order to tell about our interceptor, as usual, we will have to go to the app module, scroll down to the providers array, and here we need to add a JavaScript object. We need to provide three properties here. The first one is provide, and here we need to use HTTP underscore interceptors, all in capital letter. This is a token name that Angular will look at in all the classes and will consider those classes as interceptor and run those classes in the chain. And the second property is use class, and here we need to tell the name of our interceptor class. And the third property is multi, and it must be set to true in the case of HTTP interceptor, because it is multi-provider token, and in case we will not set this property true, it will not work. Required modules automatically be imported on the top, but in case if these are not added automatically by VS Code, then you'll have to import these classes manually at the top like this from angular/common/http. So our interceptor is now ready. Let's run our application and see what we get in the console. So if you refresh this page, we are already calling HTTP GET method to load this homepage data from JSON file using HTTP GET method. So our interceptor should be called. Yep, it's called as we get this line here, HTTP request started, that we put in our interceptor. And if we try to log in, let's just use some invalid username and password. Yep, this time as well our interceptor is called. So our setup is working fine. Next we'll see how to move all of our error handling logic in the interceptor and remove it from the component. We can use the pipe operator on this observable that will take this observable as input, and inside this pipe we can use the different RxJS function, and to catch the error we will use catch error. This method has one argument to get error, and type of this error is HTTP error response. And in this method we can log the error. Let's copy all the code from our component and paste it here. Remove this line as it was wrongly imported. And this alertify is a service, and in order to use it here, we will have to add the constructor in this class and inject alertify service here in constructor. And finally, it is important to return an error from this function. Let's throw error and return error.error. You can see all of these modules are automatically getting imported here at the top of this class. Just to remind you, sometimes it does not work in VS Code and you have to manually import a few modules here. Also, you need to add this injectable decorator at the top of this class, and it should be provided in root. Otherwise, this alertify notification will not work. So now we can remove this error handling code from our component class. Let's try to log in. First, provide some invalid username so that we can see if our interceptor is catching our error or not. Perfect, we are getting this alert from our interceptor. And if we provide the correct user ID and password, yep, we are successfully logged in. That means our interceptor is correctly passing requests further in the chain. Now we can remove this error handling code from the register component as well, because our interceptor will work globally for all HTTP requests. We do not need to put this error handling logic now in any component or service. Let's try to add a user that already exists, and it should throw an error from the interceptor. Yep, we are getting an error notification from the interceptor. So happy paths, or we can say positive test cases, are working fine. Let's test it for a few negative test cases as well next. Let's see what will happen if our API server is down. Trying to log in, doesn't matter if we use invalid or valid user, as our API server is down at the moment. Definitely our interceptor has catched this error, but we did not get any clue in this notification of what wrong has happened here. And if we look at the console, you can see this time we get this JSON object in error. It is not directly exposing the error as we were getting previously. And if you look at the other nodes, you can see we get status as 0 here. So whenever we do not get any response from API or API server is down, we always get 0 here in the status node. So we can use this status code in our interceptor to display unknown error, or something else you would like to display to the user on the base of this status code. Let's create a separate method to set the errors instead of directly putting if-else condition here in the catch error block. Accept the error response here as an argument that we will pass from the catch error block. This method will return a string type. Let's define error message and set the default value as unknown error occurred. There are two kinds of error that usually occur in Angular applications. One is client-side error that we usually throw from the front end. We can identify client-side errors by checking the instance type using instance of type, and client-side error instance type is error event. So we can handle client-side error in this block and set error message here. We get the error message in error.message node for client-side errors, and all other types of error are server-side errors. Set the error message error.error and return this error message here. At present, we are throwing all non-error in this format error.error. But as you have seen, if our server is down, this is a kind of unknown error, and we got a JSON object in that node. You have seen it results in throwing a blank notification to the user, and we know if the server is up, error.status will not be 0. So if error.status is not 0, we will set the error message using error.error. And as we already have set the default value here, and if all of these conditions are failed, this method will return the default value as unknown error occurred. Let's use this method here in the catch block. Define a constant, name it error message, and set its value using this dot set error, and pass error in the argument, and use the constant here in both the places. So if now we will try to log in, perfect, we are getting this unknown error notification. So it is working fine for both the test cases, like for the handled error that is returned by our API, and the second test case is also handled to return an unknown error if the server is down. The handled error that is being returned by our controller is defined here. So when the user was invalid, we are throwing this error in error response. Let's think what will happen if in case our API server is running but our database server is down. That is also possible in real world scenario. Let me stop the SQL Server instance so that we can replicate this issue in our web API. We are not handling this error in our controller, and our exception middleware should catch this error. And you can see we are returning all unknown error response using this class. We have some properties here to set error code, error message, and error details. And if the environment is development, we are returning this error trace as well. But we are not returning the error trace in the production environment. And this is totally a different kind of JSON object that we are returning from here in case of unhandled error. So our database server is down. Let's see what will happen if we try to log in now. Again, we got blank notification this time. And the reason is we got status code 500. That is not 0 this time. So our interceptor did not consider this as unknown error. And error code contains a JSON object that contains 3 different properties, but our interceptor is accepting a string in the error code. So to fetch this error in our interceptor, we will have to use error.error message here. But we are still getting blank error. Let me check the node. Maybe I have made some spelling mistake. Yep, got it. We are returning these 3 properties in Pascal notation. The first character is capital, but if you look at the other nodes, we are getting nodes name in camel case notation. So either we have to use here as well as Pascal notation, and if I change the first letter capital here, we should correctly fetch the error. But I do not want to go with this approach and would like to keep the same standard for all the error nodes. Let's correct this behavior at API level instead of renaming it to the Pascal notation. So go to the API error class, and here we are serializing this object. By default, .NET use Pascal notation for JSON serialization, but we can also set the camel case using the JSON serializer option and set the property naming policy to JSON naming policy dot camel case. Now we can pass this option as the second argument of the serialize method to tell that all the properties should be serialized in camel case. save it and let's try to log in one more time. Yup, we get this error detail now that is thrown by our API middleware. We are getting so much detail in this error because we are running our API in a development environment. But if we will run it in the production environment, we will get only internal server error here in the notification. You can see now we are getting all the properties here in the camel case notation. So it is working fine for unhandled error now, but it will start to fail for the handled error that we already have tested. Because in our controller, we are not using the API error class to return an error response. So we will use the object of the same class here as well for the handled error in all of our controller. We should always be consistent in returning error response so that our API client should not have to put so many if-else cases to correctly display the error at their end. So let's define a variable of type API error. It seems we do not have a constructor of this class that accepts null argument. That is why I'm getting this error here. Yes, we do not have that in place. Let's add one more constructor with a blank argument here so that we can instantiate the object without passing any argument. Save it, and now error has gone from here. We can now set the properties of this object here and set error code equals, it should be the code of error that we are going to return in the response. We can use unauthorized dot status code here to get the correct error code for unauthorized error, and set the API error dot error message. Just copy this message from here. And also we can set the third optional argument here to set the error detail, where we can provide some details of this error. Let's tell the user that this error appear when provided user ID or password does not exist. And finally, return this API error object here in response. Let's run the database server and test if we are correctly getting this handled error or not. And if I try to log in using invalid user ID, yup, we are getting the correct error. And in the console, we are getting JSON object in the error node with all of these three properties that we are setting from our controller. So we have tested all these three test cases. One when API server is down, and another when database server is down, and the third one when the handled error is thrown by our API. And all of three are working fine. And also we need to update this register method as well to return error using the object of type API error. So this time I have not set error details here. Let's test it by trying to create a user that already exists in the database. Yup, we are getting error properly on the component as well. And in console, if we examine this error node, we get null in error detail property, as we are not setting anything for this property in our controller. So we have successfully implemented global error handling using Interceptor in this video, and also updated our API to return consistent error response in different methods. We were also supposed to fix this issue as well by putting a validation check to return error in case user tried to pass a blank username or password in this video. But video has become little lengthy, and so I would like you to take it as an exercise. As a hint, we need to put a check here in the register method. We need to check if the provided user ID or password is blank. Then we will have to return this bad request, and we should return the error response using the API error class. You can use a string.isNull or empty function on the user ID and password for this check. And if that is true, you need to return the bad request. If you are not able to do that, no worry. I will explain the same in our next video, and we'll also see how to add an extension method to incorporate null check more efficiently so that we can use that extension throughout the application. Also, we will see how to implement retry logic in our interceptor so that HTTP request should be able to retry automatically in case some connectivity issue happen during the HTTP calls. And also please tell me some more scenarios that we can implement in our interceptor. Feel free to ask if you have any question. Please like this video if you really learned something new in this video, and see you in the next video. Stay tuned. Bye bye.